Happy Monday. And happy President's Day. For some reason, everyone else in government gets off, but we don't. All the integrals you've looked at so far have been what's called proper. So remember, with fundamental theorem of calculus, there are two conditions. F of x, your integrand, had to be continuous over the entire interval, and the interval had to be finite. What if it's not? Then we call it improper. Two categories of improper: your interval is infinite, or your integrand has a discontinuity over the interval. And for each of those two categories, you have three cases. We'll start with infinite. A to infinity. Negative infinity to b. And finally, negative infinity to infinity. The first scenario, we just pass it through a limit as b approaches infinity and then integrate a to b. Second scenario, replace negative infinity with a and then pass it through the limit as a approaches negative infinity. This third scenario, pick some value.
Right.
It doesn't matter. Typically we use 0.
You split it into two halves.
Then you just split it into 2. So again, typically we choose 0. But you can really choose any convenient value. And then obviously now you have the sum of the first two scenarios, and then you know what to do. Your second category you're going to have an integral that looks like your standard integral. A to b f of x dx. First scenario, the integrand is discontinuous at your lower limit. So it's discontinuous at A.
Is that supposed to be a negative sign?
No, it's just a hyphen to
Oh, okay.
indicate cases. What we do replace the A with R, and then we pass it through a limit. But A is the lower limit, right? Do we care about values less than A? Which means there's a right-handed limit only. All right, we're in the interval A to B. Values less than A we don't care about. Second scenario, your integrand is discontinuous at your upper limit. Replace B with R, pass it through a limit. What values do we not care about?
The one's higher than B.
So this should be a left-handed limit, right?
Yeah.
Final scenario. Your integrand is discontinuous at some point in the interval. Call it C.
What's that symbol between this and the B?
This means in, element of. Just split it at that point of discontinuity. Now you have a sum of the previous two scenarios. First case is easy to determine. Right, you can see right off the bat is your interval infinite. This one you now gotta be careful. You can't just blindly use the fundamental thing of calculus anymore. You have to actually make sure that your integrand is continuous over the entire interval. Clearly this integral is improper. Right? The interval is infinite. So this is going to be a key piece of information we want to keep in the back of our minds. That bar is going to be positive. First thing you want to do, replace minus infinity with a. Now pass the integral through the limit as a approaches minus infinity. It doesn't have to be a, it can be r, t, any letter. Except for x, where you can't use your dummy variable. In this scenario, you don't really want to use little r either. Right, 'cause it's already used. What's that antiderivative?
It would just be e to the r, right? It would not be, okay.
Over x,
Not over x.
but our x is gonna be u sub or no?
There's going to be a u sub. What is u?
Or x?
What is du with respect to x?
R?
It's just r. So it's over r, not over x.
Oh, yeah.
That'll be evaluated from a to 0. So when x is 0, what does this evaluate to?
1 over r.
Now it'll just be e to the AR over r. What is that limit?
Like as r gets bigger, the number gets smaller.
When is r getting bigger?
No,
No, right, r is just on constant.
yeah.
So what is that limit?
Oh, r is the constant, so
0?
You're thinking just 1 over r, isn't it?
yeah,
Limit of a constant's a constant.
yeah. Yeah, I guess it can't go anywhere.
What about this limit? Remember, a is going to minus infinity. Just use this color.
Does that mean the number's getting bigger?
A isn't.
Well, A isn't, but that EAR over R will be getting will be an increasing number
Would it?
as A goes to negative infinity. Yeah, because it's like makes the reciprocal.
Right.
Yeah.
So is that getting larger? What happens if your denominator gets larger?
Well, the denominator gets larger.
What happens to the overall fraction?
It gets smaller, but it's
Well,
over.
as you just said, right? A is
Right.
going to minus infinity, so this acts like in the denominator.
Right. But
With
then
A
it's-
getting larger then.
But then it's over R.
Right, but R is in the denominator and it's constant.
Also, it doesn't become reciprocal or anything. Okay.
Well, this does. Right, so you could also look at it this way.
So I guess the number is gonna be getting smaller and smaller.
Why is it getting smaller, smaller and smaller?
Because the denominator is getting bigger and bigger.
Right.
Because if it's an absolute.
But how do you know that this is going to stay positive? Because if that exponent's negative, it's going to move back up to the numerator.
Right.
So how do you know?
Because it said earlier, it has to be, yeah.
Because r is positive.
Yeah.
So what is that limit?
I mean, I guess it's 0.
Yes?
Yeah, it's 0.
That limit's 0. So what we're allowed to do then is split this into two separate limits and take their difference. You're left with 1 over r. If those limits exist, we say the integral converges to that value. If the limit does not exist, we just say the integral diverges. So in this case, the integral converges and it converges to 1 over r. So a quick note about notation. Once you get to more advanced courses, so like in my physics courses, we wouldn't be going through all this crap. We would just write this. With this being an implied limit. Right, so you might see something like this. This is an implied limit, which is 0. So just keep that in mind. If you ever see minus infinity actually in the evaluation, you're not evaluating at infinity or minus infinity, right? Because that doesn't make sense. It's not a number. It's always implied to be a limit. In this case, I'd say it's the limit e to the x over r as x approaches minus infinity, which is 0. When we move on from this, we start looking at series. You may see me get lazy and revert to that notation. I like this one. So again, quite obviously, this is improper, right? What makes it improper? It's infinite.
strict sub or no?
You don't have to. Also check, here we don't have to worry about it because E is continuous everywhere. That's a fraction, denominator can't be 0. Will that denominator ever be 0? No, so we don't have to worry about that. It's not,
a square.
we don't have that improper. So what is that antiderivative? So you can use trig sub, but you don't have to.
Ln of,
Can't do u sub.
I think that's the inverse tangent.
It is an inverse tangent, but it's not just inverse tangent. Half inverse tangent of x over 2. Again, it's one of the basics on your table of integrals. It's, what is it, number 16? I think it's the last one of the basics. Or maybe second to last. Last one will be the secant, inverse secant. Well, I can only do that if the limit actually exists, so I'm not going to do that just yet. What's the inverse tangent of 0? Zero. So this is all we're looking at. Now we have a bit of a problem. If you just look at b over 2, what's the limit of that as b approaches infinity?
Infinity.
Infinity. So I can't use the composite function theorem because that limit doesn't exist. What I can do, though, is make a little change of variable, just to make it easier to see. Say that b over 2 is now theta. Well, we just said as b approaches infinity, b over 2 also approaches infinity. So theta would approach infinity. So I can write it this way. Again, it's not necessary, it just makes it easier to see. What is that limit? First off, if you ignore the half, does that limit exist?
Tangent of infinity? No.
Inverse tangent.
Inverse tangent of infinity. No.
That limit does exist.
Cannot equal 0.
Is it like a
Does not
repeating
equal
thing
0.
or something?
Huh?
Is it like repeating?
So this limit does exist. So I can factor out the 1/2. So another way of thinking of this, what is the range of the inverse tangent? No, you don't remember this. That makes me very sad.
Yeah, I have a picture of it.
That makes me very sad. It's the last thing we did before test 4 in pre-calc.
Oh, I think it might be negative pi over 2 to pi over 2?
Minus pi over 2 to pi over 2 open intervals.
Yeah.
Because tangent is discontinuous at minus pi over 2 and pi over 2.
Yeah.
Okay? Tangent sine over cosine, right?
Mm-hmm.
What's cosine of minus pi over 2 and cosine of pi over 2? They're both 0.
Yeah.
Right? That's why tangent is discontinuous. What is sine of minus pi over 2?
Square root of 2 over 2.
1?
What?
Is it 1?
It's not 1.
Negative 1?
Negative 1. Pi over 4 is root 2 over 2.
Right.
What is sine of pi over 2?
That's 1.
That's positive 1. You get negative 1 over 0 versus 1 over 0. It's like minus infinity and infinity. And in fact, if you look at the graph of tangent, tangent approaches infinity as we approach pi over 2. Which means that limit is pi over 2. The inverse tangent would have to approach pi over 2 as your angle approaches infinity. Or not angle, what you're taking the inverse tangent of, right? Because remember, the inverse tangent is an angle.
Yeah.
That integral converges to pi over 4. One of the many definitions of pi. 4 times that integral. The interval's not infinite.
It's just discontinuous with the upper limit.
But the integrand is discontinuous. So upper limit, we're approaching from the left. What is an antiderivative?
Let's see, maybe some 1/3 inverse sine
Of what?
of 1 minus x squared.
Again, you can do trig sub, but it's not required here.
I don't know why it just looks like a trig sub to me. There's no way.
Because of the square root.
Yeah. Can't say anything else.
Right, so you're right, you can do trig sub on it. But this is one of the basic forms.
We believe it's a 1/3, we'd have to factor out, right?
You would have to factor out a 1/3, yes.
Yes. Which would be 3 minus 1/3 x squared.
Inverse sine of x over 3. The 1/3s actually wind up canceling out in this case. Because you'll get an extra, you'll also get a, so you get a 1/3 and then you also get a 3 out of this.
So then is it just 1 minus 1 over 9 minus x squared?
Alright, so now evaluate it. We're going to get what's inverse sine of b over 3 minus inverse sine of 0.
Yeah.
What's the inverse sine of 0?
Um, 0?
0. Does this limit exist? What's the domain of the inverse sine?
-1 to 1.
Inclusive? So closed on both ends?
Yes.
Yes. What is the limit of b over 3 as b approaches 3 from the left?
1?
Is that in the domain of the inverse sine?
Yes.
Then this limit is just the inverse sine of 1,
Yeah.
which is what?
1? 0? -1?
Sine of what angle is 1?
Oh, pi over 2.
Because remember, the range of inverse sine is minus pi over 2 to pi over 2. That's why it's pi over 2 and not like by pi over 2.
Okay.
There's your antiderivative. Or there's your integral, pi over 2. But remember what an integral is. What's the interpretation of an integral?
Area?
Area
Under
under a curve, right? Between the axis and the curve. So the previous two, the interval was infinite, but the area existed. The area was not infinite, it converged. In this case, we have an asymptote. And the area wound up being finite. Let's actually look at that one. For now, let's go minus 1 to 4. Okay. Oh, wait a minute. Oh, where's my mouse? It should be a divided by. That's better. So here's the asymptote. So the area we're actually looking at is everything. But remember, this line is approaching 3, right? So it's getting closer and closer to 3. So that area is not infinite. So if you imagine now your y-axis extending up forever, right? So imagine then this area extends up forever. This sliver, though, is going to get smaller and smaller and smaller.
But it keeps going up that way.
Right, but that little area, that area is decreasing. So if you just imagine that entire area is pi over 2.
But does it ever touch? Like, does it ever connect?
No.
So how is that infinite?
Yeah.
It never connects.
Welcome to the wonderful world of infinity. So we say the area is pi over 2. It's not really. It's converging to pi over 2. Right, so it's approaching pi over 2. So it's going to be slightly less than pi over 2. But infinity is weird.
It's like you can keep going up, but
Right. So, but yeah, it's going up forever, but the area as it goes up, that little bit keeps decreasing.
so that it never actually.
So it's actually, so that area, that extra area keeps decreasing specifically to 0, which is why the overall area converges. But it's not like that area is getting larger. The area is getting smaller. It's funneling in.
In such a way that the area would never
So,
actually.
in such a way, the area does exist. It's not an infinite area.
Right. Okay.
And it converges to pi over 2. Just wait till we get to infinite series, and I found the number file finally did another video on it, so I signed it as an extra assignment.
Like extra credit or something?
No,
Oh.
it's just another assignment that's now been added in.
Oh, okay.
But it is really interesting, and if you're not used to infinity and the way mathematics works, completely blow your mind.
Sounds like it'll be fun.
It is. It's also still very hotly debated. The result. It's still a very hotly debated result. Half of the community accepts it, the other half doesn't. I'm in the community that does not accept it. Even though I've looked at the proof and I've read the proof, and the proof is sound if we assume that the one theorem they're using is true, because it hasn't been proven yet. But the result just makes zero sense. Something to look forward to. I think that's week 11. But again, it just gives you an idea of how weird infinity is. By the way, that result is used in string theory, which is physics. So it actually does have a real-life application. I don't know why you popped up. I don't want you. I want you. All right, so again, keep in mind, that's what we're doing in all this, right? We're finding areas. Is the interval infinite?
No.
No, certainly not. Is this integral proper?
No.
No. The integrand has a discontinuity where?
In the upper limit, that's it.
We have a discontinuity at 2. Again, it's upper limit, so we're only approaching from the left. What is that antiderivative?
Would it be an ln?
Would be a log function, yes.
Yeah. So I think it would be ln of 2 minus x.
You're very close. You're missing one thing.
Is that negative 2 minus x?
There's a negative.
Oh, negative log of 2 minus x. Absolute value.
What's the derivative of 2 minus x?
1. Negative 1.
That's why you need the negative.
Okay.
Now, 2 minus x from 0 to 2, not including 2. Always positive, isn't it?
Yes.
I actually don't need the absolute values. Because 2 minus x is going to be positive over our interval. So you just drop the absolute values, you don't need them. Again, you're not wrong if you keep them in. There's another way we can write this though, isn't there? Not that it really matters, but I can get rid of that negative by making this 1 over 2 minus x.
Oh,
Right, because I just raised the entire 2 minus x to the minus 1 power.
okay.
Ultimately, it's not going to matter.
Is that gonna be -1? Do you believe as x approaches 2?
So since this is negative,
Yeah,
I'm going to do 0 first. I'm going to flip the order.
okay.
Right, otherwise, it's going to be negative this minus negative at this, which becomes positive.
Okay,
So I'm just going to do 0 first.
okay.
And say that's what? Natural log of 2, then minus natural log of 2 minus b. This is a constant. What about this limit?
As b approaches 2, that's gonna get smaller and smaller to 0. And the natural log of 0, I believe, is 1. It's not a 0?
So know what natural log is. Another way of saying natural log of 0 would be e to what power gives you 0?
So it doesn't exist.
There's no power. It does not exist. We're approaching from the left. Right, so we're approaching from values smaller than 2, which is fine, right? That's going to exist, because that would be positive, not negative. That's actually negative infinity. If you look at the plot of natural log, as you approach the y-axis from the right-hand side, the positive values, natural log decreases without bound.
Okay.
This limit's minus infinity. Minus negative infinity is positive infinity. Log of 2 minus positive infinity.
It's positive infinity.
It's technically negative infinity.
Oh, 2 minus positive infinity. Yeah, okay, yeah. Negative infinity.
I'm sorry, it should have been plus, right? So it would have been positive infinity.
Yeah, positive.
That area is infinite. Now, even though we write this, because it gives us a better idea of what's actually going on, keep in mind this still means the limit does not exist. It means our integral diverges. Specifically, in this case, we would say it diverges to infinity. Right, so this is again a weird case where you actually look. Yes, that area is getting smaller and smaller, but it's not decreasing fast enough to converge. So the area is infinite. Weird things happen at infinity.
So what is the difference between the left case and the right case? If technically the area is in both.
So it's essentially the speed at which that area is shrinking.
How can we tell the speed by looking at the equation? Can we?
Yeah, it's just comfortability with functions. So natural log is a very slow function. Well, in this case, I'm actually looking at 1/2 minus x. I'm sorry, that's the actual function we're looking at, right? So I was doing the wrong area. It's something like, what? From 0 to 2. This. No. Got that bass backwards. Looks the same though, doesn't it? Kind of.
Well, where's the answer to?
At 2. So in this case it was at 3.
Okay.
Down here was at 2.
Where's 2?
But the general shape itself looks the same. Or similar.
So pretty much the speed is the only difference?
Well, yeah, I guess 2 is further away.
So look at the y-axis. We haven't even hit 1 yet with the 1/square root. Here we're already up to 6. So the actual graph itself is blowing up a lot faster, which means that area is shrinking a lot smaller than the previous one. So it's the speed at which you're converging to the asymptote that is different.
If the derivative of the function is the rate of change, can we, like, through derivative, tell the speed somehow or no?
It is not going to give you speed at which it's approaching that asymptote. It would give you speed of a particle following that trajectory, which is something completely different. This is why math is awesome. 2 similar shapes, 2 completely different results. Weird stuff happens at infinity. Not infinite, so that's good. Is this proper?
No,
Nope. Why?
it's discontinuous at one. Which
And 1 is in our interval.
Yeah.
So B is approaching 1 from the left in the first one. A approaches 1 from the right in the second one. What is that antiderivative?
Natural log.
Nope. Not a natural log.
It is dx. Oh,
That power is not 1. That power is 2.
oh, so we have to write this as negative 2. So this will be x minus 1 negative 2.
Negative 1 over x minus 1.
Yeah.
That goes 0 to B. Plus same thing, negative 1 over x minus 1. Except now we go from A to 4. So again, that's negative. I'm going to flip the order in which I do this. At 0, we get negative 1. At B, minus 1 over B minus 1, right? So there's that limit. Now we approach 1 from the right. It is negative, so I'm flipping the order. 1 over A minus 1 minus a third. What is that limit?
Is R4?
Huh?
Is R4?
R.
As B approaches R.
That's 1 from the left. Is that 1 over 0?
Yeah. Oh, so it's undefined now. So I guess that will.
Because we're approaching from the left, this is minus infinity.
Yeah.
which means we get -1 plus infinitely large. That entire limit is infinity, which means I can stop.
Oh, because infinity plus anything is just still gonna be infinity.
This limit does not exist, which means the sum's not going to exist. This integral diverges. But just for fun, what is this limit?
As A gets bigger?
Now a approaches 1 from the right now.
Okay.
So it's still 1 over 0, right?
Right.
Except now this is going to be positive.
Yeah.
Positive infinity minus a third.
It's still positive. Yeah.
This whole limit also happens to converge to infinity, or diverge to infinity. Ultimately, this integral diverges to infinity. So I'm just going to go that whole thing is infinity. The only difference is the power. It's now 1/3 power. Which means it's still going to be improper. Still going to have the two limits. What is this antiderivative? So what's the derivative of x minus 1?
1.
So you can treat it like u. What's the power? It's u to the what power?
1/3. Oh.
Minus 2/3.
Minus 1/3.
Okay.
Power rule
Oh, because it's
for
on the
integration.
bottom. Yeah.
Negative a third plus 1 is 2/3. 3/2, x minus 1 to the 2/3. We get what? B minus 1 to the 2/3 minus 3/2 of negative 1 to the 2/3. Oh, I forgot to write A to 4 here. Then it'll be 3/2 of 3 to the 2/3 minus 3/2 A minus 1 to the 2/3, right? What is this limit? As B approaches 1 from the left.
Negative 3/2 to 2/3, which is a constant. So that first one, if you, as it approaches 1, it's going to be 0, right?
So this limit is 0.
Right.
We're left with negative 3/2 times 1 to the 2/3, or negative 1 to the 2/3. What's negative 1 to the 2/3?
It's still negative 1? Positive 1?
It's positive 1.
Yeah. So we're just left with negative 3/2.
What is this limit as A approaches 1 from the right?
It's going to be 0.
We're left with 3/2 times 3 to the 2/3. What is 3 to the 2/3? Keep it in mind. Three halves times the quantity, cube root 9 minus 1 is our integral. This integral converges. Wait a minute, but the only thing that was different was the power. When the power was 2, it diverged. When the power, or not 2, when the power was negative 2, it diverged. When the power was negative 1/3, it converged.
So like switch up whether it's even or odd? Or
Has to do with the power.
I guess it evaluated to a different
So,
integral.
watch the video, because I discussed what's called the P integral. And there are two types. One if the interval is infinite. The other one if you have a discontinuity. And whether it converges or diverges and what it converges diverges to is all dependent on the power. That will be used later. The P integral will be examined again later when we look at series. And I believe I prove one of them and I leave the other proof to you. Is this proper?
Probably not.
Why?
Probably wouldn't be doing it if it were proper, but it must be discontinuous.
Yeah. Who knows? I could throw a proper one in there just to throw you off.
Even if P over 2 or not? It doesn't. It is continuous P over 2?
It is discontinuous in pi over 2.
Yeah, why?
Pi over 2 is not in the domain of secant. Is there anywhere else secant is discontinuous on that interval? Because it could be discontinuous a finite number of times and still be improper. The answer is no. Pi over 2 is the only discontinuity. So you also have to keep that in mind. Let's say I made that 0 to 7 pi over 4. You'd have 2 points of discontinuity. Pi over 2 and 3 pi over 2. So you have to split it at both pi over 2 and 3 pi over 2. So keep that in mind as well. You have to split it at every point of discontinuity.
Oh, that's why we have the test.
It's the upper limit, so we approach pi over 2 from the left. Integral from 0 to b, secant x dx. What's the antiderivative of secant?
Secant tangent?
That's the derivative.
ln. Secant tangent?
It's not secant times tangent.
It's not?
Secant plus tangent.
Yeah.
Oh,
Natural log of secant plus tangent. Both secant and tangent will be positive over this interval, right? We're in quadrant 1. So I don't need the absolute values. And that whole thing will be evaluated from 0 to b. So we start with b, we get natural log secant b plus tangent b minus, what is secant of 0?
Zero.
One.
Or undefined.
It's 1, right? 1 over cosine.
Oh, it's cosine. Okay.
So that's 1. Tangent of 0 is what?
1.
0. Natural log of 1 is 0. So this entire piece just goes to 0. It is just 0. What about here?
Would that also be 0?
Tangent of pi over 2 is what? Oh dear. Undefined.
Yeah, sine over cosine, it would be undefined.
So what is this limit, just of secant b, as b approaches pi over 2 from the left?
Infinity?
It's positive infinity.
Yeah.
What is tangent of b as b approaches pi over 2 from the left? I'm sorry. From the left, no, it's not positive infinity. It's negative infinity.
Okay.
No, from the left, no. Confusing myself. Pi over it's infinity. I'm looking at value smaller than pi over 2, that's infinity, yes. What about this one? We approach pi over 2 from the left. Tangent.
I think it's still undefined.
It's also infinity. So this is kind of like natural log of infinity, which is infinity. Oh, limit is infinite. Which means that integral diverges. So really, improper integrals, we're still using the fundamental theorem of calculus, right? The only difference is we now have to pass it through a limit. But isn't the integral a limit? So we're passing a limit through a limit. Oh my.
Because at the not included
Yeah, we've
particular
we've gone inception. We've now got limits inside of limits. Oh dear.
Why is the integral
That's just the definition limit of a Riemann sum.
okay.
The integral is the limit of a Riemann sum. So it is a limit. So is a derivative, by the way. Well, what have we studied so far in calculus? Derivatives and integrals. All we've done is limits. Congratulations. 2 semesters and you only do one thing, the limit.
Probably gonna be more after this though.
Series are limits too, as you'll see.
Also more world.
Yeah, it's literally just all limits.
Okay.
Even Calc 3 is really just limits. Just multi-dimensional limits. Calculus is really just the limit. And it's different applications. Right, because again, the derivative is a limit.
Yeah.
And so is the integral. It's a limit.
No limits, how many limits we could learn.
Any questions on improper integrals? Then here's what I'm going to do. You have an exam due on Wednesday, don't you? Use the rest of the time tonight to work on it. My math is also due on Wednesday. 4 people have an account, 1 person's all caught up. Another one's almost caught up. So the rest of you have a lot of fun in 2 days. And examine all the homework to do. They will all be due on the 21st. We are done with integrals, by the way. Well, techniques. On Wednesday, we will start looking at applications of integration. And we start with probably what's going to be a review, area between curves. Because that can be covered in Calc 1. Enjoy the rest of your evening. See you again Wednesday evening.